The MCAT Podcast, session number 83. A collaboration between the medical school headquarters and Next Step Test Prep, the MCAT Podcast is here to make sure you have the information you need to succeed on your MCAT test day. We all know that the MCAT is one of the biggest hurdles you'll face as a pre-med, and we're here to give you the motivation and information that you need to know to help you get the score you deserve so you can one day call yourself a physician. Welcome to the MCAT Podcast. If this is your first time joining us here, welcome. We take questions from Next Step Test Prep, either from their Q banks or from their books or from their full-length practice exams, and we cover those with Brian Snedeker from Next Step Test Prep. Or sometimes we'll talk general MCAT stuff like, are you ready to take it? Or let's talk about the new user interface from Pearson and the new testing center at Pearson. This week, we're going to cover some physics questions for you, so let's go ahead and jump right in with that. All right, Brian, we've been covering foundations of biochem, chemistry, and I'm going to guess this is some foundation of physics that we're going to do today.
Yep. So foundation of physics is movement and energy. So we're going to be looking at that today.
All right. If you want to follow along with this handout, go to the mcatpodcast.com/83 and you can download the handouts. So let's start with question number 4. Which of the following are base units in the SI system? 1 kilometers, 2 grams, 3 seconds, or 4 kilograms? We have A, 1 and 2, B, 2 and 3, C, 3 and 4, or D, 2, 3, and 4 only. So the SI system, I forget what the SI stands for, but it's the metric system, correct?
Right, yeah. Le Système International.
Yeah.
Right.
Not the American system.
Right. Everywhere but America, Britain, and I think Ghana. Everywhere else in the world uses metric. Yep.
Yeah. I wish we did too. All right.
And the funny thing is, Ryan, you know what you buy every single – well, you shouldn't buy this every day, but there is a thing Americans buy every single day in metric. Soda. You go buy – why do you buy a gallon of milk but a 2-liter bottle of soda?
Yeah. I heard an interesting – it was a podcast, believe it or not. I listen to podcasts. It was a podcast about this particular subject, and they stated that the pound is actually – that like the standard of the pound is based off of a kilogram.
It might be now. That wouldn't surprise me.
Yeah, now it is now. There is wherever it's being held, like the kilogram, everything is based off of that, including the pound.
Huh.
So it's interesting.
Well, I think you just answered part of our question then.
All right, so let's talk about it. So the SI system. Kilometers, I would assume, is part of the SI system. Everything.
Well, no, wait, Ryan, I'm going to cut you off there for a second. Yeah. The question was base unit.
Oh, base unit.
Right, yeah. Notice that Roman numeral 2 was grams and Roman numeral 4 was kilograms.
Kilograms, yeah.
So one of those is the base unit. The other one is the derived unit.
Aha. Okay, so you have to know the lingo. So base unit would be gram and not kilogram, correct?
Oh, no, it's actually, believe it or not, it's kilograms. So somewhere in like France, there's this block of metal that is a perfect kilogram.
Yep.
And that's the base unit. Yep.
Okay, interesting. Yeah, so that's the same thing. And that's why you told me. You're like, you answered the question. So base unit is the actual standard.
Mm-hmm.
Okay. Interesting.
Yeah, and just for a test strategy perspective, once you recognize kilograms, Roman numeral 4, that actually narrows it down to C and D, which are 3 and 4 or 2, 3 and 4. Yeah. So we don't even have to consider 3 anymore, seconds, because a second is another base unit of the SI system.
Yeah. And so I would go to C because we just said that gram isn't a base unit and D includes grams. So I'd go with C, 3 and 4 only.
Yeah, absolutely right. Yep, C is the right answer there. Yeah, gram is just derived as 1,000th of a kilogram. Kilometer is not a base unit. A meter is a unit. Yeah.
Okay.
Okay.
Why is that
So
important?
why is that important? Well, the
Yeah.
MCAT will actually expect you to know the difference between base units and derived units. They'll expect you to know your units. And that's kind of about as fundamental as it can get in measuring the world, right? What are the units we use to measure the world? And so,
Okay.
hence this question.
Okay.
Okay, let's talk about energy. Question number 8. A 12-kilogram bag of clothes is lifted until it has 360 joules of potential energy. Approximately how long will it take to hit the ground if dropped? A, 0.3 seconds, B, 0.6 seconds, C, 0.8 seconds, D, 6 seconds. I will just add, Ryan, you and I had talked some time back about, math on the MCAT. These answer choices are a little close together. 0.3 and 0.6, I mean, that's obviously a double difference, so that's not that close. But 0.6 and 0.8 are kind of close together. And so maybe this question is a little trickier than most MCAT questions would be.
Okay.
Just by virtue of B and C being pretty close together.
Yeah.
Yeah. And so this is going to be kind of mathy. I did try to pick one that you can hopefully just follow along if you're listening. If you do happen to be somewhere where you can grab pen and paper, maybe pause and try to work it out. But I'll go ahead and just walk us through the math here. So it told us 360 joules of potential energy. And so the equation we have to know for gravitational potential energy is MGH. That's one of the classics. Potential energy is MGH. So our potential energy was 360. Our M, the mass, was 12. G, we just round off to 10 for the MCAT. And H, we don't know. So that's what we can figure out. So we take the 360, divide it by 10. That gets us down to 36. Then divide by 12, divide out the mass. That gets us down to 3. So our 12-kilogram bag of clothes is 3 meters off the ground. And now the question is, how long will it take to hit the ground if dropped? And if they don't tell you otherwise, we have no reason to assume that there's, don't worry about wind resistance and so on. That stuff all comes out in the wash. No pun intended about the bag of clothes. So here we're just dropping an object from 3 meters, and we should certainly recognize that everything falls at the same acceleration. If it falls at G, 1G, 10 meters per second squared. So then we have to say, okay, dropped from 3 meters, how fast are you going? Or I'm sorry, how long does it take you to hit the ground? And the kinematics equations that we need to know, there's several of them. The particular equation that we could use here is distance equals v initial times time plus 1/2 at squared. And the nice thing about that equation, again, it's distance equals vt plus 1/2 at squared. The nice thing about that equation is that if you're just dropping an object, it has no initial velocity, right? You just opened your hand and then it started at an initial velocity of 0. So you can drop out that whole chunk of the equation, which means your equation simplifies to distance equals 1/2 at squared. And we know what the distance is, 3, and we know what the acceleration is, 10. So we're just solving for t squared. So again, distance equals 1/2 at squared. The distance is 3. So first thing we do is just double it, right, to 6, right, because you're going to multiply the 1/2 over to the other side, divide the 1/2 over to the other side. And then we're going to divide by 10 because the acceleration is 10. So our 6 becomes 0.6. And now we've got 0.6 equals time squared. Now, again, Ryan, we talk a lot about how you don't have to be super precise with the math, but one thing we do have to have is pretty solid number sense. You have to know what happens to a decimal when you take the square root of it, because you've got 0.6 equals t squared. So the square root of 0.6, oh my gosh, how am I going to do that without a calculator? And the answer is you don't have to. When you look at the answer choices, remember they were 0.3, 0.6, 0.8. And so the answer is not 0.6. The answer is the square root of 0.6. Mm-hmm. And then the MCAT does expect you to know that when you take the square root of a decimal, it gets bigger. So the square root of 0.6 is 0.8.
That's a lot of math for that one.
Yeah, well, it was 2 equations. Yeah. And so the 2 equations I want to make sure everybody walks away with are potential energy is MGH, and the kinematics equation, distance equals VT plus 1/2 AT squared.
So for me, having been in the Boston area for so long and a wife who did her residency at Mass General Hospital, there's a lot of potential for doctors who go to and graduate from MGH residency. So potential energy, MGH. There you go.
Yeah.
That's how I would remember that one.
Fantastic.
All right, question 9. Jesse's high school physics class is running a potato cannon competition. The goal is simple. Shoot a potato the greatest possible horizontal distance. Right now, Jesse's cannon shoots potatoes at a 30-degree angle from the ground with a total velocity of 14 meters per second. What changes can Jessie make to increase the distance her potatoes travel? 1. Increasing the velocity to 18 meters per second while keeping all other factors constant. 2. Decreasing the masses of the potatoes to make them fall more slowly. 3. Changing the angle to 45 degrees with respect to the ground. 4. Changing the angle to 90 degrees with respect to the ground. And it says here, notice that cosine 30 equals 0.87, the sine 30 equals 0.5, cosine 45 equals 0.71, and sine 45 equals 0.71. So A is 1 only, B 1 and 2 only, C 1 and 3 only, or D 1, 3, and 4 only. So you want the greatest distance. And so right off the bat, 4 doesn't sound right, because if you shoot it straight up, it's not going to go anywhere.
Mm-hmm.
So I would get rid of D right off the bat.
Yeah, because it's not just greatest distance, but the question said greatest possible horizontal distance, and shooting it straight up is a good way to get no horizontal distance.
Correct. And so D is out, increasing the total velocity to 18 meters per second. So,
well, Ryan, once D is out, look at all the remaining answer choices.
Yeah. So D is out. Then we have 1 only, 1 and 2 only, 1 and 3 only. So 1 has to be right. And now the question is 2 right or is 3 right as well? And so I think I remember way back in the day that the optimal angle for shooting anything is 45 degrees. So I would say 1 and 3 only.
Yeah, absolutely right. If you want to maximize range, shoot at 45 degrees.
Woohoo! I got it right.
Perfect. Yeah, and Roman numeral 2 says decreasing masses of potatoes to make them fall more slowly, which is like, what? Everything falls the same.
Yep.
Right? Everything falls at G, so 2 is self-contradictory.
Okay.
All right, let's wrap up our work in MCAT fundamentals with physics question number 11. Consider a positively charged particle that is experiencing a force due to an external electric field. Which of the following are conserved for the particle? Potential energy. Sorry, this is Roman numeral question 1. So Roman numeral question. So Roman numeral 1, potential energy. Roman numeral 2, kinetic energy. Roman numeral 3, total energy. Roman numeral 4, momentum. So we're experiencing a force.
So Ryan, like the dark side or the good side?
I suppose it doesn't matter, right? Yeah. Because if anything experiences a force, what's it going to do in response?
It's going to move.
Well, that's what Aristotle would have said. He would have said force creates velocity. But then Newton came along and actually figured out his famous equation, F equals ma.
Yep.
So it's not that force creates velocity, but force creates acceleration. So yeah, it's going to move. And in fact, it's going to move faster.
Yep.
So one of the first things we can say is, well, if you're going to start moving faster and faster and faster as you push on it, then momentum's not going to be conserved. It's going to go up.
Yep.
So Roman numeral 4 is out.
Okay.
And if we're going faster and faster, what else of these is going to be changing?
Potential energy?
Maybe? Well, potential is respect to like gravity or a field or something.
Okay.
But since we're the thing I was asking about was movement, like the faster you go, that's actually kinetic energy.
Yeah.
Yeah. So 2 is out as well, right? You're not going to conserve kinetic. It's going to go up.
Yep.
So Roman numeral 2 is out. That eliminates choices C and D.
Okay.
And momentum is out, but that's not even a consideration. We have to consider choice A, Roman numeral 1, potential energy is conserved, or answer choice B, Roman numeral 3 only, which is total energy is conserved. And this is just one of those foundational concepts of the universe, the law of conservation of matter and the law of conservation of energy.
Yep.
Yeah, and notice it's not law of conservation of potential energy. Potential is just a kind of energy. It's law of conservation of energy. So Roman numeral 3 that's literally always conserved. Just total energy is conserved. So answer choice B is the right answer.
At least I finally got one right.
Absolutely, Ryan. Stellar performance.
All right, there you have it. Some physics. It was funny. I saw on Instagram the other day somebody posting a comment about boxes on ramps. And when do you ever encounter a box on a ramp with a coefficient of friction? So I thought that was pretty funny and applicable to what we are doing here this week with physics. I hope you have a great week. Don't forget to check out Next Step Test Prep and their full-length practice exams. Time and time again, the feedback that I get from students just like you is that Next Step Test Prep's full-length exams are the best ones out there, outside of the AAMC, right? The AAMC makes the MCAT. They have 3 scored full-length exams that you can buy from them directly. Those are the gold standard. Next Step Test Prep is right there, next in line. You can buy 4, you can buy 6, you can buy 10, and you can save 10% off of any of those exams by using the promo code MCATPOD. That's all capital letters, MCATPOD. Hope you have a great week. Next week, we're diving into a whole series on psych and SOS. So that is exciting because I'm actually good at that stuff. At least I think I am. I hope you have a great week. We'll see you next time here on the MCAT Podcast.